I think it's the previous one.
Oh, okay. So you may need to bring down your hand, Madam Chinwe, so that I don't think you will have something to say. All right. The call is being recorded now, so we can start. We can start. Let me help Madam Chinwe to bring down her hand. So I guess she doesn't know her hand has been up. Okay, so the previous class, not the previous class, the very first class we had, we have already described the norm, the Euclidean norm. And I said that the Euclidean norm is expressed mathematically as the norm of x subscript 2. So this 2 you see here is what would make you know that this is a Euclidean norm, because for those who attended the lecture, I reminded them that we have different types of norm. We have the infinite norm, that is this norm infinity. We have the L norm, we have the P norm. So then the L, we have L1, L2, but LP, where P can be 1, 2, 3, and then we have L infinity, right? So the L2 here, which stands for the Euclidean norm, is defined as the square root of the sum of xj squared for j equals 1 to d. This is the more compact way of writing the formula for the Euclidean norm. And in the more expressive way, is written as x1 squared plus x2 squared plus dot 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 plus xd squared, where the 1 to j or j1 to d are the subscripts or the index 1, 2 to d, and then we have the squared. So if you have this x, for instance, for this is a classical example. If x is a vector from a two-dimensional vector space with the components 3, 4, if you are told to evaluate the Euclidean norm, it's simply taking the square root of 3 squared plus 4 squared, and that's going to give us 9 when you evaluate it. We can also do this in Python using Python code. So let's quickly evaluate the Euclidean norm using Python code. And to achieve that, what we simply do is we represent the norm, the guy as an NP array. So how do you represent it? We say let x be equal to np.array of 3, 4. Yeah, I believe we all remember this is how to represent vectors. So that is, now we've represented the vector x as an NP array. Now, if I should go ahead and call x, you'd see that it is an array. Okay, that's it. Then next, we want to calculate the Euclidean norm, right? To calculate the Euclidean norm, there are some steps we would need to take. So I'll break them into various steps and we evaluate it. I'll use okay, yeah, I'm going to I can actually do everything in just one code, but I'm going to break them into 3 different steps. So the first thing, looking at these steps here, the first thing is to take the square of each element in the vector, 3 squared and 4 squared. That's the first thing. So let's do that first. If I have, I'm going to say x squared. So x squared is equal to x raised to power 2. Now, I would like to see the result of x squared. So I'm going to call x squared after taking that squared. And once you do that, you can see that's how to take the squared of a vector. It's very simple. Once you are able to define the vector and you do the vector squared, this Python will simply go into that vector and square each element in the vector, no matter the dimension. And we have 9, 16, which is what we expect to have. Now the next thing is to sum the squares. Sum the squares. That is 9 plus 16. And how do we sum the squares? I'm going to sum the square by sum of x squared. We're going to sum that squared by I'll use numpy array to do that. Sum of x squared is equal to I'll say x squared, or let me do mp dot. Okay, let me try this. X squared the sum. Let me first try this, see if this will give us the same result. Sum of x squared. Okay, can you see that it gave us the same result? So there are two different ways to do it. It's either you use the dot sum method. So there's a dot sum function for any array. And I just called the dot sum function on the squared. It gave us the answer 25. Or you can also do it using mp.sum. Use the sum function for mp. mp.sum. Sorry, mp.sum. Then open your brackets, and then you can put x squared inside mp.sum. I'll do that with this. Now, if you do this, you don't have to put the sum again. So if I say mp.sum of x squared, when I run this particular code, now you can see we have the same result. So this means that I have just shown us two different ways of summing vectors in summing the elements in a vector. Please, if that makes sense to you, can you give me thumbs up? If what I just explained makes sense to you, please give me thumbs up. Hello, are we there? Good.
Yes,
Now
sir.
we've summed the elements. The next thing is to what? Take the square root. That's going to be sum. So I can take the square root using two different methods also. It's either I do, let me call it the, of course this square root is not the norm, right? The norm of x. The norm of x is equal to, it's either I say sum of x squared, sum of x squared raised to power 0.5. Then I would now ask Python to print that for me. You can see we have 5.0, which is the same thing as what we got here. Or I can say, or I can use mp, because there's also a function. There's also mp.sqrt. There's a sqrt function in mp that we can use to calculate the sum. We say have the same answer. So these three steps I took, I can take these three steps in just one code, and this is the step. I can simply calculate the norm of x as equal to mp dot square root of mp dot square root of mp dot array of 3, no, of x, sorry, I've already called it x, of x dot sum. So I can do, you can see this will give me the answer. No, before I do the sum, I'll say of raised to power 2, raised to power 2. Yeah, this is it. So this single line of code will give me the answer for these several steps that I took. If I run this single line of code, if I let me before I run the code, let's even use a different vector. Let me assign a new vector, y.mp.array. Let's call this vector, let's use a vector 2, 4, 3. Now this is a vector in three-dimensional space. So if I run this vector and I say norm of this, if I call no, this should be norm of y, not norm of x, norm of y. So when I call the norm of y, now do you see the answer? 5.3. So you can see how long all these results, all these various steps are. I did everything in just one step. So it's as simple as that. So I just expressed them in various steps for us to understand what is happening. So we can do it in a single step. Take the square of the vector, sum that squared, and take the square root of the sum of that squared. That gives us the norm of y. Do we understand, please? Perfect. So now there is also an inbuilt function in NP. There's an inbuilt function in NP that can allow us to calculate the norm of any vector very easily. This norm I calculated this way for y, I can calculate it using the inbuilt function. Let me call it norm of y inbuilt. Norm of y inbuilt. So this is a function. The function is called np dot lin arg. That is linear algebra. Lin arg dot norm of y. That's it. So if I now call the norm of y of inbuilt, you can see that we have the same result. This answer is the same thing as this, but the method I use are two different methods. Either I use the manual method. This is a manual method because I am the one that actually wrote the function or the expression. This is a manual method, and then this is the linear or inbuilt function in NumPy. Do you understand? So anytime going forward, anytime we want to calculate the norm of any function, if I ask you to use inbuilt function, this is what I mean. Use the norm function in NumPy array under the linear algebra what's it called, library. So using norm function. But if I ask you to calculate the norm by manual method, this is what I expect you to do. You have to write the code that will take the sum, take the squared, take the sum of the squared, then take the square root of the sum of the squared. Yeah. So that's it. Any question, please? Are there questions? Yes, please go ahead.
Please, can you repeat again? I kind of missed that.
I lost you at some point, so I would like you to take your question again. I didn't hear you clearly.
Yes. You were explaining something about the manual, and my network cut me off, so I don't know if you can go over it again.
Okay, so I said that when calculating the Euclidean norm of any given vector, irrespective of the dimension, you can either calculate it using the manual method. So here is the manual method, or you can calculate it using the inbuilt function in NumPy array, or in NumPy rather. So this is the inbuilt function. Now this method that I have put together in a single line is what I described in multiple lines here. Starting from here, we first took the squared of the vector. We took the sum of the squared of the vector. We then calculated the norm by taking the square root of the sum of the squared. And that gave us the norm. So I gave a different example. I gave another example with a different vector called y. Instead of going over these three steps separately, I combined all of them in just one code. It's the same thing that we've done, but just to make it a single code and keep it simple. So you can see that I took the squared of y, took the sum of the squared, and took the square root of the sum of that squared. But another method that can be used, so that is what is called the manual method actually. But I said another method that can be used is using the inbuilt function, which is this. So whenever you're given an instruction or maybe an exercise, and the instruction says use the manual method to calculate the norm of the vectors, this is what you're expected to do. But if the question says use inbuilt function in NumPy, this is what you're expected to do. So the inbuilt function is inside the NumPy package, np. There's a function called linarg. Linarg stands for linear algebra. And here is a function. There's a package or a library called linear algebra, and there's a function in it, which is norm. So linear algebra has so many functions. Let us see a list of them. np.linarg. So once you do .tab, Once you press your tab key on your keyboard, TAB, after pressing the dot, it will show you a list of all the functions. There's a function called chord, cross, det, like for determinant, diagonal, egg for eigenvalue, egg h, egg vals for also eigenvalues, egg flash. They have different functions. Inverse, this for inverse. This is the lin arg I called. So you can see the list of all the functions that comes with numpy array. Am I communicating?
Yes, sir.
Okay, so that's about that. Now, to quickly confirm that everybody on this call understand what I have just said, I want to give us a quick exercise. I would like you to do this very fast. I would like to see the screen of 3 persons. So let me quickly give you the exercise. Okay, calculate using both the manual and inbuilt function methods. Calculate the Euclidean norm. Calculate the Euclidean norm of the following vectors. So vector 1. Vector 1 is going to be the vector x equal to let me use okay, let me just present the vectors in this format. The vector x equal to -3, 8, 4, 1. Taking the transpose of that, then vector y equal to 2 comma -5 comma 0 comma 3 comma 8. Then number 3, vector z equal to 9 comma 11 comma 7. Take the transpose of that. So yeah, please, everybody, your hands should be on your computer. Kindly evaluate the norm, the Euclidean norm of these vectors. So I will give us timer. I will give us let me say 5 minutes is okay. I'll give us 5 minutes to complete that task, and your time starts now. So you can see the time is ticking. This is 4:55, 56. So I came here so you can see the question. So in 5 minutes time, I expect everybody to evaluate the norm, the Euclidean norm of these vectors. Let me increase my screen so everybody can see it. So everybody's hands should be on deck. Once the time gets to 0, I'll stop here and I'll see your screens, please. Oh, you don't have a system. You can do it with your phone. Go to Google Colab in your phone. And of course, Google Colab is in the cloud. So use Google Colab to do this. I think I've shown us how to use Google Colab. So I would expect everyone to participate, please. This is the only way to ensure that you understand what's being taught. All right, time up, please. Thank you very much, my friend. Can I see your attend? So who would like to share their screen first? Who would like to share their screen first? Okay, if no one wants to go first, I will call on names randomly. Mr. Abdul Aziz Mohammed, can you share your screen? Thank you. Let me stop sharing my for a minute. Yes, Mr. Abdul Aziz Mohammed, can you share your screen, please? I would like to see your attempt. Okay, it appears that he's not on the call. I guess he just joined and maybe he stepped away. Mr. Abdulaziz Salahuddin, can I see your screen, please? Okay, it appears that the two Abdulaziz are not on the call. Let me head on to Benjamin. Hi, Mr. Benjamin. Can you please, do you mind sharing your screen? Let's see your attempts. Okay, Samson wants to present. Samson, please go ahead. I guess the first few people on my list here, they are not on the call. Samson, please go ahead, present. Thank you. Let me see your screen. Let me see your screen. So if the time is too short, let me know. Okay, as Samson is trying to present his screen, let me just say this. It's important that you know how to do this. Like I said to those people who were around on Friday, last week Friday, that the nature of your assessment would be 60% coding and 40% theory aspect. So I just want to be sure that everybody on this call understand what we are doing. Okay, Samson, well done. So don't stop sharing your screen yet. So as you can see, Samson has written the code. He was able to present the three vectors x, y, and z as numpy array, and he went ahead to calculate the norm of the three vectors using the inbuilt function. So where is the manual method, Samson? I said we should use the two methods, both the manual and the inbuilt. You've not done that?
Yet, sir. No, sir, not yet. Let me do it, sir.
All right. Okay, so don't worry, just leave your screen up and talk us through. So maybe as you're doing it, you're explaining what you're doing so every other person can watch. So at least let's see from another person, just in case some persons do not understand at some point. So unmute your mic and do it while your screen is being shared, and just explain your steps as you're doing it. Do you mind doing that?
Sorry, sir. What do you say? What do you say? I don't get
just talk us through the process as you're doing it. Just explain it to us. Do you understand now? You have to unmute your mic because you'll be talking. Remember, you're teaching us how to get it done. Yeah.
I'm sorry. I came a bit late. I just came just now, so I was not around when you talked about the manual method, except this one.
Oh, okay. So it was just the inbuilt function method. So who wants to volunteer to explain to the class how to do the manual method? Does anyone want to do that? Thank you, Mr. Sampson. Thank you. Please stop sharing your screen. Anyone? Class rep, do you want to do that for us? Or your network is still unstable? Okay. This class is too quiet. Can somebody say something? Class rep, can you hear me? Is it only Mr. Sampson that can hear me?
Yes, sir.
Okay, you want to do it for us, right?
I'm having issues with my own system here.
What's happening with it?
It's not coming up.
Wow. That is sad. Okay, for just to save time, let's get this done together. At least when I solve this, when I write this code again, That will help those who joined late to catch up, and those who are yet to understand what we're doing to get to understand the concept. So I'm sharing my screen. Please confirm you can see my screen by giving me a reaction, please. All right, Mr. Idris can see my screen. Okay, Samson can see my screen. Samuel can see my screen. That means everybody on the call should be able to see my screen. Now, having said that, let's do this. I would add new cells here. All right. So the manual, I want to calculate the norm. Of course, when I say norm, I mean the Euclidean norm using the manual method. Using the manual method. And that's going to be, so for x, the norm of x, I call it norm of x. Norm of x is equal to, so for the manual method, I know I'm meant to first of all take the squared of the values in x. Then I'm supposed to take the sum of the squared, dot sum, and I'm also meant to take the square root. So I'm going to use the mp.square sqrt function to take the square root of this. And once I do that, I can say norm of x. Something, please. Oh, sorry. I have not defined my x. So it's still calculating the norm of the former x. So let me define my new x. X equal to mp.array of minus 3, 8, 4, 1. Yeah. So when I run this now, Samson, confirm that this norm I got is the same thing with the value you got when you use the inbuilt function. Is it the same, Samson? Hello?
Same. Yes, it's same.
It's beautiful. So any method you use, you're meant to have the same. Samson, that's the manual method. I hope you understand it now.
Yes, sir.
Then let's do one for y. So our y is mp.array of 2, minus 5, 0, 3, 8. That's it, 8. And then we can go ahead and calculate the norm of y as the y squared. Then I'll take the sum of this squared, dot sum. Then I'm going to take the square root of the sum using my mp.sqrt of the sum. And when I'm done, I'll call num y, and that's it. Beautiful. Then finally, z equal to mp.array of the vector 9, 11, 7. Right. The next thing is to calculate the norm of z, which is equal to mp.sqrt of the squared of z squared of the sum of the squares of that z. Then I'll say norm of z equals, that's it. So this is how to evaluate or calculate the norm of any given vectors using the manual method. Samson had already shown us with the inbuilt function, the inbuilt norm function in the NumPy library. Any questions? Are there questions, please? Hello, class. Are we together? There are no questions. Give me thumbs down. There are questions. Give me thumbs up. Yes, Mr. Samuel, please go ahead. I can see your hand up.
In the question, this particular vector, can you hear me, sir? Can you hear me, sir?
I can hear you very clearly.
Okay, in the question, this particular vector is carrying the transpose sign.
Yeah.
Where does the transpose comes in?
Okay, so the transpose here simply means that these vectors are presented like this.
Okay.
Yes, that's what that transpose means.
Okay.
So it's either
Okay. Okay. Let me get it clear, sir. So which means when you import NumPy and you put mp.array those vector, it's automatically transposed.
No, it's not transposing it. So what I'm trying to say is that it is either I write the vector like this, the way it is standing, like column vector, or I write it like this, like a row vector with the transpose. They are equivalent. There are two ways. There are two ways of writing vectors. It's either you write the vector as a column vector, or you write it as a row vector and you transpose it. So the transpose here is not an operation that is meant to be performed in your calculation.
Okay. Okay.
It's just a way of presenting the vector. If I want to show you that this vector is presented in a row column, in a column vector format. I don't know if what I said makes sense to you, sir.
That it makes a lot of sense. That was what caused the delay on my own part. I
Ah,
was
okay.
thinking
You were thinking
we
that you're
needed
supposed to calculate the
to
transpose
transpose it.
first. Oh,
Yes.
I see. I see. No, you don't need to transpose it. You don't need to transpose it. And by the way, if you want to transpose a vector, if I say x raised to power t and I run this, it's going to give me an error. Do you see? Because
Yeah.
it doesn't
Yeah.
know what t is. Do you understand? Yeah.
Yes, sir.
So, but there's a way to transpose it. I'll show us how to transpose it later. Um, that's this how to transpose it. Just do x dot t, but it still presented it the way it appearing because NumPy doesn't arrange vectors in straight format. But if this was a matrix, if this was a matrix, if I do x dot t, you will see that it would have transposed the matrix. Don't worry, when I introduce us to matrices, I will show us, you will see what I mean by this transpose. To transpose in NumPy, I just do x dot t. That will give you the transpose of the vector. But you will see it clearly when we get to matrices. But in this case, you are not expected to evaluate anything about transpose. Just go ahead and calculate your norm. Is that good, sir?
Yes, sir. It's fine, sir.
All right, perfect. So we are done with section 4.1. Section 4.1 is all about Euclidean norm and distance. So I believe everybody should be able to calculate that now. Now, next, let's move on to Euclidean distance between 2 points. So this is where you want to calculate the distance between 2 points. This is just Euclidean distance of a vector. Now, we want to look at Euclidean distance between 2 points. So mathematically, write it as the dist of x comma y, which stands for the distance of x comma y, and that is the norm of the difference between the two vectors x and y equal to the square root of the summation of x j minus yj all squared. This was what we evaluated in our during the lecture on Friday. For those of you that were present, we calculated the within cluster sum of squares, right? Please give me thumbs up if you are around on Friday. Give me thumbs up if you are around on Friday. We did a manual calculation of within cluster sum of squares, and in the table that we evaluated, we had to get the difference between the vector, that is the centroid, and every other point on that cluster. And when we did that, we took the squared and we did the square root. So this is exactly what we want to do using using computational techniques. And this is the key operation exactly. You see, I haven't highlighted it here. This is the key operation inside the k-means. We measure how far each data point is from each centroid. And thankfully, we did that calculation in the lecture we had on Friday. So here we would see how to do the same calculation using Python. Now imagine that you had to do, like I said during the lecture on Friday, I said, imagine you have to do this for a data set that has, let's say, 1,000 data points, because we only did for three data points in the two clusters. And you saw how long it took some of us to do it. Some people they could not complete it before I did the correction. So imagine you have to do it for 1,000 data points manually. You will be there and keep calculating and calculating. It will take a whole lot of time. This is where programming languages like Python comes in. Am I communicating, please? So we'll do simple example, and then I'll give you an exercise using the Penguin data sets that we have been working with. So let's take simple example. I'd like us to calculate the distance between two vectors. Okay, we've already defined some vectors here. I think we should continue using those vectors, or are they of the same dimensions? Yes, vector x and y are of the same dimensions. They are 4 by 4. Are they? No, vector y is a three-dimensional vector, and vector x is a four-dimensional vector. Okay, let's define two new vectors that would use, because for us to be able to calculate the distance between two vectors, the two vectors must come from from the same vector space. So let's use two examples. Calculate. Here's my example to explain this mathematical formula. Example: I want us to calculate the distance between the vectors u equal to let's say 8, 1, 5, a 3 by 3 vector, and v equal to minus 1, 7, 3. All right, so these are two vectors. We want to calculate the distance between them. All right, so I'm going to now look at what we would do. What we need to do. We need to calculate the difference between the two vectors. That's step one. Let's take a step. So I'll do it like I did in the previous example. I'll take them step by step, and then I will show us how to write a single line of code that will complete all the steps. So step one will be to calculate the difference between the two vectors, right? U and V. That's step one. So I'll call it difference. I'll call it diff. Diff equal to, so diff here stands for difference. Diff, okay, sorry, I've not even defined my vectors. Let's first define the vectors. Vector u is equal to mp.array of the vector with the elements 8, 1, 5. Please, if I am doing something that you do not understand, kindly raise your hand, please. Press this button to raise your hand if I am doing anything that you do not understand. That when I say this is an exercise and you cannot confidently do it, call my attention, please. So the reason why I'm going this extra mile showing us how to do all of this is because I want everybody to know how to do it themselves. All right, so mp.array, this is vector u, and vector v is equal to mp.array of the vectors with the elements minus 1, 7, 3. Then let's get the difference. Diff is equal to, okay, this is my step one now. So here I just define the vectors. Define the vectors using mp.array. So that's what I've done here. Then step two is to take the difference, and that's going to be what? Simply u minus v. It's as simple as that. Okay, that's the difference. So when I call diff and execute, so this is the difference, and you can check it out. 8 minus 1 is 9. That is 8 plus 1. 1 minus 7 is minus 6. 5 minus 3 is 2. You can see that this diff is actually the correct difference between u and v. Do you understand that step, that first step? Give me thumbs up if you do understand. If you don't understand, give me thumbs down. I'd like to get reactions from everybody. Okay, Irene does not understand. So can you unmute your mic and tell me at what points are you not getting it? Irene.
My network again. So I came in halfway.
It's like you're in curfew. Are you in curfew? But I know that it's curfew that has this kind of terrible network.
No, it rained here. And rain scatters our network here. So
Hey, I see. Wow. So where did you stop hearing me? At what point?
so you are assigning the U and V. I don't know. I heard you saying we'll use the the other vectors. I don't know if that is what we are using or you came up with a new one.
Okay, yeah, we actually came up with new vectors. We came up with new vectors, u and v. I will just define. Oh, excuse me. Exhausted. And we just defined the vectors u and v, right? Then we took the difference. So we are trying to evaluate the distance between u and v using this formula. So what I'm doing right now is taking the difference between the two vectors, which I have done. That's the difference. Then the next
Okay.
step 2 will be to take the squared of that difference. That's going to be step 2. Step 2, that's difference squared. I'll call it difference squared. So taking the square of the difference, and that's going to be equal to div raised to power 2. So when I call div squared, we should have squared the difference. Can you see? We squared the difference. That is 9 squared 81, minus 6 squared 36, 2 squared 4. So we've done that. And because we have only 2 vectors, right? We will take the sum. Even though we have multiple vectors, we will take the sum of these vectors. Am I communicating? We will take the sum of the vector. That's why calculating, you're taking the norm now, right? We'll take the sum and take the square root of the sum. Please, am I communicating? Can you give me, are you giving me thumbs up already? Okay, good. So let's do that and see what answer we'll get. I'm going to do the sum. I'm going to do this. I would say this is step 3. Step 3. Sum, or yeah. What do I call this now? Should I call it the sum of div squared? Sum of div squared. That's going to be equal to div squared dot sum. And when we check the sum of div squared, it should give us the sum. That is the sum, 1 to 1. Then final step, step 4, they're meant to take the square roots or the norm of the sum of div squared. And the norm is nothing but mp.sqrt of the sum of div squared. And that's it. So the answer is 11.0. That means the distance between u and v is 11. The distance between u and v is 11. Does that make sense? Please, does that make sense, please? The distance between u and v is 11. Any question?
I know what is not joke, my life. That's the question matter. I'm gonna say, don't get that.
Mr. David, do you want to ask a question, sir?
Yes, sir. Yes, sir. Throw more light on this. That integer 64, I don't understand.
Which one?
Integer 64, I don't understand there.
Oh, okay.
And the difference square.
So, don't bother yourself about all of this. The answer is just 1, 2, 1. If I use the print statement to display the sum of the difference, you won't see the the 64 again, you won't see that. You see, you just get 1 to 1. So the reason why you're showing MP float 64 or MP in 64 is because I am actually returning an MP object, a numpy object. So MP dot in 64 is telling you that the answer that is gotten as the sum of this difference squared is actually an integer, and the integer is occupying a 64-bit space in memory, and it's an MP, is a numpy object. Do you understand? But the actual answer is just 1 to 1.
Okay, okay.
Yes, it's just 1 to 1. So the reason why you're showing all of those extra, this is because I did not use the print. I can use print to make those things not to show. I can always say print sum, and I can say print the norm of the sum, and to show all those MP float, MP int, and the likes of them. Are we together, please? All right. So if I don't want to make my solution be all these long steps, I can also do the same thing. You know that this is just the norm of the difference. And we already know that there is a norm function in linear algebra function or package in the NumPy package. So what I would just do is I would say I'll only calculate the difference. So all I'm going to do is this. Please listen and watch carefully. I'm going to say the norm of u minus v is equal to, I would say mp dot what's the function again? mp dot inarg dot norm of u minus v. That's all I need to do. And when I call my norm of u and v, if I should print it, let me use print now. Print this answer that I got. You see, we also have 11. So all these plenty lines of code from this step 1 to step 2 to step 3 to step 4, I did it in one single line of code, and we got the same answer. Can we see what is happening here? So first 4 lines of codes gave me a single line of code gave me the same answer as 4 lines of code. Please, I don't know if we are following. Is this making sense? So you are free to use that single line of code, but the reason why I did that first breakdown is for us to understand what is going on under the hood. Yeah, what is going on under the hood. So that's it. So now I believe that everybody on this call can calculate the distance between 2 vectors, at least the distance between 2 vectors, right? So if I ask us to calculate distance between 2 vectors, we can do that now, right? All right, before I give another exercise, let's go to section 5. Now matrices. So I will also talk about the what's it called? The transpose that I mentioned earlier, but because now we're working with matrices, so we can see the transpose of this of matrix. Okay. The data matrix. If you can remember, we defined the data matrix in a particular, I think in section 5 of our lecture notes. So the lecture note defines data matrix as this mathematical expression. Now, each row is 1 data point and each column is 1 feature. If you remember, I mentioned this during the lecture. So we have n equal to 4 penguins and d equal to 2 features. That is for the penguin experiment that we started with in this notes, this particular note. You can see the penguin experiment and taking some measurements of the different parts of the penguin. So if we're looking at 2 different penguins and we want to evaluate four features, No, we're looking at 4 different penguins rather. 4 penguins and 2 features of the 4 penguins. We want to take the measurement of the culmen length and the flipper length for 4 different penguins. The matrix will look like this. So 39.1 and 181 is the measurement of one penguin. The penguin has 39.1 centimeter and it has 181 centimeter for the culmen length and the flipper length respectively. For penguin 2, this is the measurement. For penguin 3, this is the measurement. For penguin 4, this is the measurement. Right? In Python, we can write this particular array is a 2-dimensional array, and it can be written like this in Python. Let's call it penguin. Let's call it penguins measurements. I'm trying not to use a very long variable name. Let's call it penguin measurements. That's equal to np.array of, so this is how this is going to be expressed: 39.1 comma 181. Then you close that bracket, you put a comma. The next one, 46.5 comma 215. You close the square bracket, put a comma, go down again. If you don't want to come down, it's fine. You can have all of them on one straight line, but I don't want to use that method. This is what I'm saying. Is you can also do this way. Just say comma, you put the next one. The next one is 38.9 comma 188. Then comma, the next one is 49.0 comma 220. Close that bracket. So all of these would be inside another bracket, right? For you to represent this, they will all be inside another square bracket. Open the square bracket here and close it here. So this is like list of lists. So when you're presenting any dimensional vector space or any dimensional vector using numpy array, they will all be in a list of lists. So this particular guy, this square bracket opens here and it closes here. That is one list. And then the different measurement for the penguins will be in other lists. So you can leave it this way. You can also make it appear like this. So at least it's kind of modeled after the way this vector is expressed. Yeah. So I want to call the penguins. I just want it to display as an output once it is registered in memory. And I have given a wrong definition. I mean a wrong spelling. What is missing here? Oh, my G is missing. G. Yeah, so this is it now. So that is how to represent a 2-dimensional vector space using, why am I calling this space? A 2-dimensional vector using numpy array. Do we get that, please? Are we together, everybody? Okay. Now, what do we intend to do with this vector? We have expressed this vector in 2-dimensional space, and it makes sense, right? You can actually check the shape or check the dimension of this vector to confirm what the dimension looks like, right? You can know the dimension of the vector to confirm what the dimension looks like. So how do you confirm the dimension of a vector? To check the dimension of a vector, we use the shape.shape method. That is, I would call the penguins measurements dot shape, and that's it. Just say dot shape. Yeah. Once you call this method dot shape, it will give you the shape of the penguin's measurements. So the 4,2 here tells you that The penguin has 4 data points or 4 measurements for the different penguins, and it has 2 dimensions: the number of data points and the number of dimensions. Are we together? So anytime, so now I know somebody might be wondering, so why do I have to use this to check the shape? Can't I see everything here and just count it, with my eye and simply get the answer? Yes, for this particular data set, because it has fewer data points, yes, you can do that. But if it is a very large data set, imagine you're working with like 100,000 by 100,000 data set, or 100,000 by 347 data sets, data points and features. You can't tell the number by mere looking at it. You have to use the dot shape method to see the number of data points and number of features that your data set has. I don't know if I'm making sense. Am I communicating, please? Hello, am I communicating? Beautiful. All right. So before we go further, I want us to see how to access the elements in these data points. How to access the elements in data points. Now remember that in let me quickly open my whiteboard. Which whiteboard can I use now? Should I use Maro? Let me see if I can see access my Maro my whiteboard. I want to quickly show us something mathematically here. Give me a minute, let me open this whiteboard and show something real quick. Just starts for free. I don't want to sign in. Reject all I beg. Starts. So I need to enter in it to start for free again. Wow. Sorry, I'm trying to open. Just check your email. That is research stuff. What are they doing? My email? Just sent me a sign-in link. This Myro have changed their method of using their board. They've upgraded. I'm still with you, please. I'm still with you, please. I hope everybody is still awake and active. And Anchiwe, are you still on this call? Hello, Manachiwe. Set password. Oh. I don't want to set password by force. Manachiwe, are you still on this call? All right, so let's look at what I want to quickly describe. This thing wahala done too much. I started plenty wahala. Wait. Okay, so this is my board. Let me show something real quick. If you can see my whiteboard, can you give me a reaction? You can see my whiteboard, give me a reaction. So this is what I'm trying to say. Remember that we can have where is my pen? My pen. All right, so I don't know. So we can have all right. Oh, what is this thing's problem? Where is the pen that I just selected now? This board is behaving anyhow this evening. Smart drawing. I don't want to do smart drawing, I want to type. Okay. Let me increase my pen size to this point. Let me choose my different color. So we can have a matrix, say A. This is very tiny. Okay, I know why it's tiny. That is because it's tiny because the okay, wahala. This thing is really is behaving this night. So it's tiny because I zoomed out. Let me zoom in a little bit. So you can have a matrix A that is written as A11, A12, A21, no sorry, A13. This A13. Then we have A21, A22, A23, A31, A32, and A33. We can have this matrix like this. True or false? Am I communicating?
True, sir.
Good. So for this vector that we have presented this way, this one, the way the matrix is going to be expressed is, if assuming we want to use the same matrix A to represent it, so it's going to be expressed as A11, A12, A21, A22, A31, A33. That means we should be able to access the individual elements. If I say, what is the element A11? You should be able to give me tell me what number it is. In our particular case, it is 39.1. That is the element A11. So element A11 should be equal to 39.1. If I ask you what's the element A21, you should tell me element A21 is 46.5. 46.5. Now, the same way we can tell the different elements in various positions in your vector or your matrix, you should be able to also tell me the elements, fish out the element for me using Python code. So if I want us to get those elements out, if I say give me the element A11, this name is too long. Let me just reduce it to, because I'm going to be calling the name again and again. Okay, let me just call it PM. So PM stands for penguin measurement. Let's call it PM just to keep the name very short. Good. So we'll call it PM, please. All right. So if I say, if I want to get the element, this element, right? If I do PM of this, how to access the element, PM of 0, it will give us the entire first row. Can we see that? PM of 0 gave us the first row. If I do PM of 1, this one will give us the what? The second row. If I do PM of 2, this will give us what? The third row. Please, can we see that? That gave us the third row. So, but what if I do PM of 0 and 0? Watch this. Can you see that? 0, 0. That's like A11. So because in computing, we start our counting from 0. We start our indexing from 0. So it means that instead of saying A11, we will do, what we're going to do here is, we're going to do A00, A11, A A01, this this is going to be A10 and A11, A20, A21. Can you see that? So this is how it's going to be indexed in the computer. So I've just called PM00 because here the matrix is represented as PM. So it's called PM00. So when I say PM of 0 of 1, what do we get? 181.0. I don't know if I'm making sense at all. Am I making sense? It is good that
I'm making a lot of sense.
All right, thank you. So it is good that we know how to access the elements in our data set. We know how to access the elements in any data frame, because sometimes it will require us accessing specific number of elements in a data frame. So what if I want to try on that method and see if that will work. If I do PM of 0,0, what would this look like? Do you see what just happened? So if I don't want to say PM of 0 and 0 inside two different brackets, I can say PM 0,0. If I don't want to say PM of 1 and 1, I can say PM of 0,1. Hello, are we there?
Yes, sir.
Yes, sir.
Good. So what if I want to collect just from this element to this element, just the first two rows? Who can suggest how can we do that? Please go to the chat box and drop it there. I want to display only the first two rows like this. So what would be the code? How can I slice that subset of our array? Drop what you think will be the answer. Drop it in the chat. I want to see everybody's attempt. I hope you understand what I'm talking about. I want us to get only this item, only this one, the first two rows. Well, how can we write the code to receive or to filter out just those first two rows? What would it look like? Drop your answers in the chat. Okay, Mr. Idris, Mr. Mark. Okay, let's try. Mr. Idris, look at your bracket too. From a bracket, I would know that would not work. Let's try Mr. Mark's code here. So this is Mr. Mark's code. Let's run this and see. Mr. Mark, your code is giving us error. Your code says too many indices for array. Dimension is 2-dimensional, but 3 were indexed. So look at your code again, Mr. Mark. Let's look at Abdulaziz's code. Let me copy Abdulaziz Mohammed's code. Let's try it out. Okay, this one also says slice indices must be integers or none or any index method. So Mr. Abdulaziz, you won't give us error. Let me just try Mr. Idris' code. I don't want to condemn his code from by just looking at it. So this is for Mr. Idris. Let's run this. mp.nRA is not callable. So I already knew that it was going to give us an error when I saw the code. So we are getting error yet. We've not gotten the correct answer. Let me see whose phone will I try again. Let's try Irene's code. Irene. I've copied it. And okay, this one says list index out of range. Irene, your code gave us error. Samuel titles code. This is going to give me an error, Mr. Samuel. We are using O instead of 0. I already know that this is O, so it's going to give us an error. I'll not run it yet. Mr. David, your P is capital P. So in coding, you have to use the same letter. It's supposed to be small p. The P will use small p and small m. But you have used capital P, so correct it before we run it. Oh, Destiny. Let's see Destiny's code. I think Destiny was the first to send this code. Let me copy and try his own. You've not gotten the correct one yet, too. Oh, Destiny. Your own gave us the first row only. Only Destiny's code did not give us an error, but it didn't give us the correct answer. So it gave us the first row. So it's not the first row we want to see, Destiny. We want to see the first two rows. The first two rows like this. That is what we want to see, Destiny. We want to see the first two rows. Okay, Destiny had given us another code. Let me copy and run. Yeah, Destiny code has worked. Can we give him a round of applause? Destiny's code has worked. So Destiny gave us 0 to 2, and that worked just fine. Well done, Destiny. Well done. So 0 to 2.
Sir, can you run my last code?
Okay, that is Nathaniel, right? Or who?
No,
or
Samuel.
Okay, Samuel. Let me copy your code and run. Is it giving us error? So why did Destiny's code why did it execute? Now don't forget that we said if you give me 0, only 0, you're telling me to give me the first row, right? If you give me only 1, you're saying give me the second row. Now what we are doing actually, we are doing something like this, or rather, let me say something like this. We have to call, okay, I know why it's throwing error. So why it's throwing up some error is because I didn't put a comma, not semicolon. I'm doing something like this. Okay, let me call it like this, comma 0. Aha. Can you see this, comma 0, or this, comma 1? So I'm saying give me, this is saying give me everything in, okay, if I do like this, let's do this. You see what happened? If I do P, nothing here, nothing here, nothing in the first cell, nothing in the last, it gave us everything. So if I say give me everything, comma 0, no, give me everything, comma 0. See what it did. I want us to understand what is happening here. Now, if I say give me everything from 0, comma 1, set empty. From 0, comma 2, this can give us error. So the way to slice this your array is by we put the number of in the first cell, we put the number of items we want in the first row. We put the number of elements we want from the first row, because we know the first row has whatever we need here. Whatever you want from your column, right? Whatever you want from your row is what you appear here. And what you want from a column is what you appear here. So I want 0 and 2 columns. That is why it gave us this, and it gave us 2 columns, column 1 and column 2. But if I want to display the 0th column, when I say the 0th column, what do I mean? I want to display 39.1, 46.5, 38.9, and 91.0. That is the column I want to display. So what I will say is, give me everything in the row. Okay? Everything in the row, comma, give me the 0th column. If I do this, that was what I ran earlier. So what it is showing us here is the first column in our data set. Let me even call MP again so that I don't have to be scrolling up, so we can see it easily. Let's call MP here. So you can see that what is showing here, the output is giving us here, is the first column, everything in the first column. But if I want the second column here, right? How can we select the second column? I would say give me everything in the row and this second column. So this is what's happening here. So right now, it's showing us everything in the second column. 181, 215, 181, and 220. Please, am I communicating?
Sir, please come again, I beg.
So what I'm saying is, here, if you want to select everything in the first column, just this column here, what you will do is you will call the name of the vector and say everything. So if I put this, in fact, the way of writing it is, you are saying, whenever you see this full column here, it's like you're saying, give me everything. The way it works is you give it, you can either say, give me 0 and 1. You know, when we run this code, the 0 here represents the number of the position of the row. The 1 here represents the position of both the row and the column, because if I do 0, 0, it's giving us just the dimension. From 0 to 0, it says it's an empty space, so there's nothing. Is 0 to 0. But 0 to 1 give us the first row. 0 to 2 give us the second row, and the second matrix. 0 to 3 give us you can see that it's increasing. But this 0 to 4 to give us everything. But when you say give me, so you don't put 0 here at all, just full colon, and you put a comma, and you say 1. Let me start with 0, and you say 0. That gave us the first column. This is how to select the first column. When you do this one as 1, it gives you the second column. That's what I mean. So this is how to slice or access a subset of your data. A subset of your data. But when you pick a point, just one point inside, like this one now, this is going to be 0, 1, 2, 0, 1. So it's supposed to be 2, 1, 8. That one, 8, 1. You say, give me P of 2, comma 1. And that will give us 188 rather. 2, comma 1. That means there's the second 0, 1, 2, the third row, and the second column. But normally, if it was mathematics, if it was a mathematical way of writing it, the normal way of expressing it would have been PM of 3, comma 2, right? PM of 3, comma 2. This would have been the normal way of writing it mathematically, because this is the third row, second column. But because our counting starts from 0, because our counting starts from 0, we do 0, 1, 2. That is why this is the second row, and then 0, 1. That's why this is the first column, and that's how we got that item. So it is important to understand the way to slice this array to get the items in the array, because we would need to do some slicing when it is time for us to evaluate some points from an array. We need to do some slicing. That's why it's very important for you to know how to slice. Any question? Are there questions? Okay, in the absence of question, let me ask us a question. Please, I need us to drop the code. How do I access this row, the last row from this matrix? I want to access this last row, only this one. So drop the code on the chat. Give us the code to access this last row on the chat. Everybody, please drop the code. Okay, Nathaniel has dropped his code. Let me copy Nathaniel's code. Copy, and let me paste his code here. Nathaniel, this is what he gave us. He gave us the third row, but I want the fourth row and not the third row. Okay, sorry. Okay, I said it. No, I think I said the third row, right? The fourth row, right? Okay, Ibrahim has given us his code. Okay, let me first run Destiny's own. I love Destiny's code. Destiny gave us P of -1. He's using the negative indexing to evaluate that, and that's correct. Can you see? So as much as we can index from top to bottom using positive indexing, we can also do negative indexing. Nathaniel had given us his code. Let me run Nathaniel's code. So Destiny's code is correct. Let's run Nathaniel's code, and that's also correct. Let's run Ibrahim's code. That is Ibrahim Badmos. Let's run his code. And Ibrahim, see your code. Your code gave us the subsets of the vector. It gave us a 3x2 matrix instead of a 1x2 matrix. So the correct answer is either you do P of 3, or you do, PM of 3, or you do PM of -1. Any of these two will give you the answer. So I'm happy that a lot of us are getting this, and we are actually able to access the elements in the array. Well done to you all. That's a very, very fantastic one. All right. At this point, I'd like to take questions if there are any, and if there are none, I think this is a good place to end this class today. Because I don't want to start with this sample mean, the centroid. That is what we're supposed to start with, but I don't want to go into that now so that I don't rush it. And yeah, and I myself, I think I'm exhausted. I need to rest. So are there questions? There are questions.